Example 1 says determine visually whether each of the graphs is symmetric about the x-axis, the y-axis, the origin, or neither. If the graph represents a function, determine whether the function is even, odd, or neither. So, part A here, is it symmetric with respect to the x, y, or origin? So if it's respect to the x, split it along that x. Is the top the same as the bottom? And no, those do not mirror each other. So it's not the x-axis. Is it the y-axis? And yes, this side here mirrors the right side. Okay, they're not identical, but they do mirror each other. So if you took this and you flipped it over, everything would land on top. So this one is mirroring along the y-axis there. So is it a function? Well, we can tell if it's a function by that vertical line test. So if it's a function, then we should be able to put a vertical line anywhere on that graph and it only intersects once, and it does. So yes, that is a function. And so is it even, odd, or neither? If it has y-axis symmetry, that means it's an even function. So because it is y-axis, that makes it even. Okay, and more specifically, because it is only y-axis, that makes it even. Okay, part B, is it symmetric with respect to the x, the y, or the origin? Okay, if it's with respect to the x, does the top mirror the bottom? And yes, it does. Okay, if you take this and you flip it over that x-axis, it's all going to land on each other. So it has x-axis symmetry. Whenever you find one, though, you can't just be done. Because keep going through, and does it have y-axis symmetry? Well, yes. If you split it right here along that y-axis, the left side mirrors the right side. So this also has y-axis symmetry. And then also, if you take your paper and you flip it upside down, this is the exact same oval that it was before. So it also has origin symmetry because we can rotate it 180 degrees and it looks the exact same. So this one has all three types of symmetry. Now, is this one a function? And the answer is no, because I can put a vertical line and it intersects twice. That means it is not a function. It does not pass that vertical line test. So if yes, but it's not a yes, so we don't have to answer that question. Part C, what kind of symmetry does this one have? So if we start with the x-axis, then the top does look the same as the bottom. They mirror each other. If you take this top half and you flip it over, everything's going to land on each other. Think of those ink blots, right? You fold the paper in half on what picture do you see? Kind of the same thing. So we have y-axis or x-axis symmetry there, but we don't have y, because if you look at it on that y, the left side does not mirror the right. You've got something on the left side, but you have nothing over here on the right side. So it's not y-axis. And if you kind of notice, this is kind of opening up right here to the left. If you flip your paper upside down, now it's opening up to the right. So it does not have origin symmetry either. Is this a function? And that is no. When you put a vertical line in, it intersects twice. So it is not a function. So I don't need to answer that second one. Part D. Does it have x-axis symmetry? Nope. The top of this graph does not look like the bottom. Does it have y-axis symmetry? Nope. The left does not look like the right. Now, if that vertex was right there, we could have y-axis symmetry. If this was my y-axis, then the left side of the parabola would look like the right side of the parabola. But because that vertex is not on that y-axis, it does not have y-axis symmetry. And then if you rotate this 180 degrees, Now that parabola is opening down, it was opening up. So this one actually has no symmetry. Now, is this one a function? Yes, anywhere you put that vertical line, it only intersects once. So is it a function? Yes, passes the vertical line test. And so then if yes, is it even, odd, or neither? Well, for it to be even, it has to have y-axis symmetry. For it to be odd, it has to have origin symmetry. Because it has neither y-axis or origin, that makes this one neither. It's not an even nor an odd function. Okay, part E on the next page is the symmetric with respect to the x-axis. Here's my x-axis. So no, the top does not look like the bottom. What about the y-axis? And then yes, the left side mirrors the right side. So this one has some y-axis symmetry. And then what about origin? Well, these arrows are pointing up. If you rotate this paper, now they're pointing down. So does not have origin symmetry. Is it a function? Yes, because anywhere you put a vertical line, it only intersects once. And so if yes, is it even, odd, or neither? Y-axis is even. So even because it's y-axis. Okay, and then our last one. Is it symmetric with respect to the x? Well, no, the top does not look the same as the bottom. What about with the y? Nope, the left side does not look like the right side. But if I open this, notice it's going down on the left, up on the right. If I rotate this 180 degrees, does it look the same? Yes, it's going down on the left and up on the right. So this one, if we rotate 180 degrees here, we have origin symmetry. Is this a function? Yes, because anywhere you put a vertical line, it only intersects once. And then if yes, is it even, odd, or neither? Well, if it has origin symmetry and only origin symmetry, it should be odd. So O for origin, O for odd, right there.